right, so a lot of what we're doing in this chapter is going to feel very familiar as you covered it in middle school. Some of you even covered it in your K through 5 science experience. All right, so here on this April 11th, 2016, quarter 3, week 11, the students will be learning about parties up here. All right, so we're talking about transformations of atoms. Can someone remind me what an atom was? What is an atom?
Smartest.
You know what I mean?
Like,
Give me a break because I don't have no small things to make a bag of coffee.
Something about small.
Is it small or
All
something?
day. I
All right, so it's the smallest unit.
What colors does he want?
A lot of folks doing the wrong thing. Their eyes should be up here. Their mouths should be blue. Yvonne's looking up here. Right, so it's the smallest measurable item of mass, right? And if you take a few atoms together and stick them together, what do you get? A molecule, right? So you take atoms.
Mr. Cabadagli, I can't find purple. Can I just use blue?
Excuse me, Victoria.
All right, and if I take a bunch of molecules and stick them together, I get the smallest unit of life, which is a
Victoria.
Oh,
a cell, right? If I take a bunch of cells and put them together,
tissue.
I get an organism, or I get a tissue, then an organism, and so on and so forth, right? So what we're talking about here is how is it these atoms are moving through living things in the environment, right? How are they getting from place to place? As we get to our start question, you are given a little puzzle, and again, based on your previous science experiences, as well as just logic, rearrange these terms into a logical order. I'm not giving you any hints, not going to send you any direction. In 6 minutes, I can make this people forward. I mean, do it on your paper. On your paper.
Claudia, what you trying to make it, huh?
Oh yeah, she's outside. Alright, so taking this time again, you are rewriting this into the correct or the most logical order based on your thought. Right, so so doing it in your head and on your paper.
I don't even have that. Everybody loves using the word cat. It's right there. It's right there.
All right, folks who are using the packet, it looks like Ms. Tassari did not include today's lesson in it. So,
Just use a simple piece of paper, please.
all right,
I don't even have paper.
I don't know, like, what might make sense? Like, I'm not giving any hints, I just want people to think, like, look at it. You could do it from that way. You could also do it by...
Can I have that paper?
Alright, folks, so again,
Is that donated to the class?
Mr. Captain, this is not part of today's notes?
she apparently did not include it in there.
Never mind.
This part is not?
Do we have to learn it down?
Yes.
That means no.
It's been 32 weeks of high school. I think we've set the precedent for the expectation. That if it's up here, you put it right there. Alright, so,
You think you're smart?
He does have like a big
alright, so, which one of these things, just looking at it logically, do we think would be the first thing we put in the list? Alright,
sun.
why do we think the sun might be the first thing?
Because then it goes from the two, and then it goes
If we're going from the two,
This is the
The sun is where all the energy in our solar system comes from.
Then flower. What?
That paper isn't it not good?
It is true that if you don't bring your own things, you have to just take what's given to you.
Exactly.
Then the sun to the flower.
All right, so the sun is going to give energy to the flower.
And then the insect just takes the whatever from the flower.
All right, and then the insect is going to get atoms and energy from the flower.
And then the rat eats the insect.
All right, then the rat might consume the
And then
insect,
the cat eats the rat.
and then the cat might eat the rat.
And then the hog gets the cat.
All right, great.
Oh my God, there's a song like that.
All right, so if you did not put that in the proper order, please do so now. We're going to revisit this as class goes on. So, and also in terms of writing it, when you put it in the right order, you may have, or you may not have, done something like this. If you're just writing it for the first time, please use the arrows. And if you just had a list before and you can fit a little arrow in, that'd be great, but it's not going to make or break it. But it will be helpful. All right, so mosquitoes remind us that we are not as high up on the food chain as we think, right? As humans with egos, with consciousness, we often believe ourselves to be the apex organism in the environment, right? We take from everything, but what do mosquitoes get from us? Blood, their food, right? So in fact, we are not the top of this food chain, right? There are things that are feeding off of us. You'll also notice at this time that it says part 1 of 4. So just like with the chapter 12, we've got some readings and some questions that go with them. I'm going to send a stack back for each row. So make sure you take one of these. The first set is should be done tonight. The entire thing is due the Tuesday after break. So that means you're getting 2 weeks to get this done. And let's be super extra double conscious and clear about it. If I'm saying that the Tuesday after break is the due date, that is April 26th. If you think you forget, go ahead and write April 26th at the top of the paper. If April 26th is the due date, does that mean you can show up on April 26th and say, may I hand this in tomorrow?
No.
But what could you do, Kelly, instead?
Before then?
And hand it in?
Earlier.
Early, right? So the 26th is the last day I will be willing to accept this from you.
I know y'all peep that.
But you can always hand it in early. You can even hand it in like tomorrow. All right, so just again, keeping in mind that it is a due date, not I'll think about doing it now and handing it tomorrow date. So there's these 4. One of the activities will have an extension that you may or may not finish in class, but for the most part, this will be the whole thing. Assuming you work productively in class, right? It's 4th quarter, yeah. And Ruth brought up the other good point. Given that this is the only chapter occurring in 4th quarter, what does that mean for the weight of this homework and your actual grade? It's really heavy, right? Missing this automatically cripples your grade for quarter 4, right? Which is why I've given you 2 weeks to do it. All right, let's move on.
No. Yes.
Where can you find these things, Victoria?
I don't know what's that because I'm not looking for it.
Well, that's your choice. All right, so we've used this word biotic a few times before, but this is our first time adding a formal definition to it. Luckily, all of my sweet, kind academic freshmen know what the prefix bio means. Life or living, right? So biotic refers to any organism.
What if you don't have that in your packet? Should you just put it at the bottom?
So like I was saying before, so the package is missing this particular thing, you have to just put the whole thing as a piece of paper. Yeah. Right, so this is when an organism, parts of an organism, or the products of an organism, in some kind of system, in an environment, right? Whether it be an ocean environment, or a forest environment, or a lake environment, or a desert environment. And we want to be clear about what we're saying by components of or products of an organism. If an organism leaves behind a pile of feces.
Use that as soil sometimes.
And then you can grow flowers and then from the flowers
Indeed,
you
right?
can grow pollens and then from pollen.
Yeah, right, because all the nutrients you didn't use. Right, so we're saying this is a product of an organism, right? The feces is something the animal made and released. But in addition to being something an organism made, what else does feces have that would help it categorize as biotic? What else is in there other than... There's some nutrients in there that weren't used. What else? Is there anything living in the feces? Sometimes these things are parasites. Single-cell organisms without a nucleus.
Prokaryote.
Bacteria, right? Prokaryotes. Right, so feces also contains living things. Right, so feces is considered biotic, one, because it's made by an organism, but also because it has living things in it. Right, so some examples of biotic things. We talked about 6 of them, actually. 6 categories of living things. What do we call those 6 categories of living things? It's a kingdom, right? So
Oh my god, you're so
our
smart.
kingdoms are examples of biotic things, right? There's our archaea, right? There's our archaea, there's our eubacteria. Right, so this is a good opportunity for us to revisit some earlier topics and start doing some tie-in.
No, it's not revisiting. Your whole lesson went into a full circle. That's what you just did.
Right? Someone knows what he's doing up here. Alright, so these 2 things here, these 2 kingdoms, people might remember those 2 kingdoms have something in common. We have our archaea, which live in extreme environments, and our eubacteria, they live inside a host. They're both prokaryotes, very nice. And, Javon, that means they lack what? They lack a nucleus. Right, so remember that these 2 things are prokaryotes, they don't have a nucleus. That means their DNA is floating around in that jelly of the cell known as the... There's like that substance all throughout the cell, the organelles are all floating in it. Cytoplasm. Right, so the DNA is free floating in the cytoplasm. Now, by contrast, these 4 friends also have something in common. What do all 4 of those things have?
A nucleus.
They have a nucleus, and the nucleus contains all the
DNA.
DNA. Very nice. Right, so folks might remember, what do we call the organisms that have a nucleus? Eukaryotes. Right, so we have prokaryotes and eukaryotes. Alright, and folks that forgot their materials, it is the 15-minute mark, so you're welcome to exit the classroom if you need to get whatever you need. Alright, so, also in our environment, we have abiotic things. Anytime we see the prefix a in front of a word, what does it do to the word? Non, it negates it, right? Asexual, you don't need sex to reproduce. Asymmetrical, you are not the same on both sides. Atypical, you are not in the norm, right? So, obviously we know these are the then non-living things, right? So these abiotic factors in a system, what are the non-living things in the environment?
Fires.
Right, fire, rocks, water, right?
Solar elements.
Nice, right? All the things that have not come together into an organism yet, right? So something that is non-biotic.
That one's orange. Underline orange.
No, I was just using the color to emphasize the A.
Oh.
Yeah. We'll use the colors to come up. The 3 secondary colors, which are secondary colors. Anybody?
Green, orange.
That's primary. Green, purple, orange. Awesome. All right, so light, as we know, light is a requirement for many living things, but it's not a living thing itself. Temperature, right? We need to be at a certain temperature in order to survive. But again, temperatures, it's not alive, it's just a condition that living things need. Right, nutrients, wind, rock, soil, pressure. Some new breaking news out there in science for those that read the newspaper or the science section. They just discovered a way to measure something that before we didn't quite know what it was. It pulls on everything in the universe. Gravity. Right, before we didn't understand this whole gravity thing, and now we actually have a unit of measure for it. I just read the headline here, but I didn't read the whole thing.
Wow.
All right. Whoops. I didn't expect anyone to ask. What happened there? it's gonna be a note heavy day. So I hope your hands are feeling strong.
Oh my god.
Everyone's done. Alright, so many organisms, right? So many of the organisms within several of the kingdoms are what are known as autotrophic. So let's take a look at this word here.
Trophic.
Alright, so whenever you see it here, what words start with auto?
Automobile.
Autobiography.
Autobiography.
Automatic.
Automatic. Catalina,
I just thought of that too.
Maya Angelou autobiography.
who writes an autobiography?
Yourself.
Yourself, right? An automatic door, who opens it?
Yourself.
It opens itself, right? So the prefix auto indicates self, right? So
Alright, what's your small board?
usual business, right? So so an auto always means self or of one, right? And so it's autotrophic. These are organisms that can make their own food. They can make their own organic molecules. And once again, this is a lovely time for a little review / tie-in. What are the 3 organic molecules? Carbohydrates. And what do carbohydrates give us?
Energy.
Energy for when?
Storage.
Later or now?
Later.
Nah.
Now, right? Carbohydrates are energy for now. Those are your sugars. What's another organic molecule? Proteins. And proteins are for what? Building tissues. And then what's our 3rd organic molecule? We had carbohydrates, right? What's a fancy word? Lipids. Our lipids, and lipids do what with energy? Store it for later, right? So our 3 organic molecules, that means these autotrophs, they can just make all this stuff on their own, right? They can gather materials from the environment, a little light, a little water, some carbon dioxide, and bang, they can make a molecule that they can nourish themselves with, right? So they can make these things from non-living things. Can we do this? No. Like, can I like lie out in the sun and just like feed myself from that? It would be nice.
I hate that.
We are. Yes.
I'm like, they say that like all humans they give off like 10% of their brain.
So different parts of your brain, right, function for different activities. Remember from chapter 1 there was different regions, right? A lot of those neurons are available for use, but unless you do certain activities, you're not going to use them. All right, so now we get our food from a different place from our body. What's our fancy bio prefix meaning different? The opposite of the same. So we have homo, which means same, then the contrast is hetero. So we are what's known as heterotrophic.
Oh my gosh.
Right, so hetero meaning different, meaning that I can't get food from my own body, I have to get it from a different place, a place other than myself. Alright, so our heterotrophic, these are our organisms that gain organic molecules by consuming other organisms. Maybe they're eating plants, maybe they're eating fungus, maybe they're eating other animals. Maybe there are plant that eats animals, right? But either way, these are organisms that cannot produce their own food. They have to gather these nutrients and units of energy from others. Folks in the back, is there too much glare? Can you guys see okay? You can pull the shades out a little bit. So, now that we've got these 2 definitions, right? We have our organisms that can make their own food, and we have organisms that have to eat others in order to get nourishment, to get their food. What do we think trophic might mean or relate to?
Food.
Probably food or eating, right? So we got this word trophic in both of these things, right? And trophic, right, it refers to eating or consumption, or obviously the eating of food, right? So let's go ahead and add that above trophic on one or both of those places. Trophic meaning eating or consuming. Right, so autotrophic literally means self-eating, like they can make their own food. Right, heterotrophic, self-eating, they have to get their food from a place other than their own body, from a different source. Good.
Who keeps saying, oh God?
And
Like,
20
every time I
seconds.
speak. Go, sir.
Okay. Alright, so now this all leads us to what we did in our start question, what we did in the do now earlier, the food web. Right, this food web is a complex system. How would you define complex? People saying difficult. What makes something difficult or hard?
A lot of
Everything.
A lot of, right? There's multiple parts, many things, right? A simple system is one that might only have one or two components, whereas a complex might have, 2, 10, 20, 2,000, right? So a food web is a complex system, meaning it has multiple parts.
So in the packet, none of the words are going to be on the book.
The
That's just
lesson
like,
for today is not on the packet. Write it on a different piece of paper.
Yeah, but I'm just saying, like, I'm just asking about.
yeah, I think when she was transferring stuff over, she just missed this one.
Okay.
Yeah, we'll just staple that in afterwards.
Okay.
All right, so the complex system of multiple connections, right? Now we start off with that very simple food chain in our do now, like sun to flower, flower to insect, insect to rat, so on and so forth. But is that like the only story we could tell with those organisms? Like what else could happen in that scenario?
rat is a snake or something.
Well, I mean, you could introduce new organisms into the chain for sure. But are there things in that system we draw that could have eaten something else other than what we drew?
Like the
Perhaps, right? The hawk might. Right. So if you are a hawkling, like a baby hawk in the nest, and there's some insects, you could potentially consume those, right? Skipping all that middle stuff. Has anyone have a pet cat? Ever seen them like
A
eat a
dog,
bug?
like dogs chew grass.
Yeah, right. And maybe a larger animal like
Grass.
right might eat the grass, right? So the food web is this idea that it's not just a straight line of a viscid fat that eats this. It's that multiple things might be, taking sampling from different parts of the buffet.
Oh, I've made food.
All right, so you don't necessarily write this. We'll just talk about it. Right, an arrow is what's used to show who and what direction the eating is happening. For example, if I have a mouse and an owl, why is the arrow showing the mouse to
Because
the
the
owl?
mouse is being eaten by the owl.
Right, so the mouse is going into the owl, right? And what two things is the owl getting from the mouse? Energy and protein molecules, right? So this part I do want you to write down, this example. And this arrow represents energy, and this arrow represents molecules. Right, so this arrow represents energy and molecules. So what we're saying is the owl is taking in all of the energy and molecules of the mouse, right? They're absorbing its life. And folks earlier in the year asked about reincarnation, like, do people believe in reincarnation, so on and so forth, right?
I do.
In a loose sense, this represents that, right? The death of this organism, right? Or, it's all the things that this organism live on in the owl, right? It's molecules, so on and so forth, right? So, life does continue, just in a different form.
Get stabbed with this.
She's not doing it. She's capable. All right, now's the part we like the best when we start using our colors. What's a synonym to make something? Like factories do this. Manufacture, we have produce, right? So organisms, and we use our green for this. So highlighting in green, underlining in green, writing it in green. We have our producers, right? And we know that to produce something, right, is to make it.
Victoria.
Thank you, Victoria.
No, I know this girl did not. Are we kidding?
face down like this.
In the front row.
Where she's not invisible. You don't get that choice, Victoria. Do I?
Girl, you're sitting in the front row. Not with your head down. Not even looking at the station.
I'm teaching and you're on your phone. I think you're a little confused about what respect means, darling. So.
Can I teach? So, guys, this is the
Alright, listen. seconds anyway. So. Okay, producers,
These are
the autotrophic members of a food web that undergo photosynthesis and create food eaten by other organisms. Write it down, guys. You guys have 2 minutes.
Photosynthesis. These are like.
Who's over here making noise like we
She know.
Me.
Les? We can't make it.
Me.
No, you sing. They be making noises like
Y'all need to stop.
That's
Childish.
Oh my god, Victoria, just give him the phone.
No. You're gonna get it through the phone.
Barely. But, yeah.
depends how many times he's
Should have never been on the phone.
Victoria,
You get it taken away before?
is this your first
Multiple
time?
times, yes.
Oh my, but you're sitting in front of class.
Alright, so,
Come on now.
You ain't doing it.
and from the top of the class, folks, I just want to remind people, right, that this chapter is the only chapter in the grade, meaning the professionalism for this grade is also the only professionalism grade you get for the whole quarter, right? So, therefore, be on your best behavior.
This is all for quarter 4?
This is all gonna be quarter 4. Yeah, quarter 3 done. I'm all set with it.
We gonna be on our best behavior.
All right, so, producers are organisms that can make their own food. They are autotrophic. They use the process known as photosynthesis, which we've talked about a bunch of times. And they can create, the food they create, the sugars, the lipids, the proteins, are consumed by other organisms, right? That's why everyone is after the plants. Yeah. Yeah, that's what we're doing right now. Yeah.
That line kind of makes sense. Create food eaten by other organisms.
Right. So like if I'm a horse, right, I can't make food in my body, but I can, but whatever the producer made, whatever it created, another organism. Right. Okay. So eventually we are all going to die, and we will be consumed by decomposers.
No, because I'm fighting.
Yeah, or if
So-
you're in a coffin, the worms eat you and stuff.
That's how I want to be.
All right. So if you, so you can use your purple for that. You can use your purple for that, please.
Yo, I cannot. I'm still.
All right.
I'm gonna be.
Now, what is it to compose something?
It
break
means
it down.
to eat something like.
Compose, not consume.
Well,
Just right.
compose.
So like you
Break it down. Is that purple?
I
No.
just said that and he said no.
Like this.
right. So just
Compose it.
compose. Like I'm composing a letter, or I'm composing a scene.
So only write compose. Making. Body.
I'm just breaking the words up.
Is it making?
All right. So to put together to create. I look how you were trying to blame the Asia before, but it seems like was there.
Where about Victoria?
All right. So,
Here you go.
but when you see the prefix de before something, right? Deconstruct, decompose, destroy. What's usually happening? Yeah, taking apart, right? So rather than producers are composers, right? They pull different molecules in, they turn it into something amazing, and then our decomposers do the opposite, right? So we have make and break, right? Decomposer being the opposite of our producer.
So how do they get through the coffin, or do they just take coffin out and close it?
Coffin's just made of wood.
So they just be like,
If you just eat the wood.
Yeah, like remember, it's just a box of wood in the ground. It's getting wet. It kind of disintegrates over time.
I'm gonna do a metal box.
There's actually some really cool ways to deal with your remains these days. So, like one of the things that you can do now is they expose your body to liquid nitrogen, and it removes all of the water from your body and turns you into like a little cracker. And then they just like smush it up, put it in the ground, and then plants absorb you, and that's awesome. You can also they'll plant you in the roots of a small tree, and then like your family can like put you in the yard and
Your tree?
your tree.
They also they can turn you into a diamond. They can.
I was just gonna tell you about that. So there's also this place called Life Gen where if you get yourself cremated, your loved ones can ship your ashes to this place, and they put it in a machine that puts a lot of pressure and heat on it, and you come out a diamond. And for a small extra cost, they can add certain minerals to the diamond and decide what color crystal you'll be.
I'll be a diamond because I've got birthstone.
So anyhow,
Why would you want to be?
and transform it into useful stuff again.
So what they're basically trying to do is
Which of our kingdoms are decomposers? So thinking back to our kingdoms. Our fungi for sure. Who else is a decomposer? Our fungi are decomposers and our bacteria, right? Some bacteria. All right. And are there animals that also eat things that are no longer alive? Yeah, animals are also decomposers. Right? We ourselves are decomposers. If you're eating a bag of Cheetos, is that a living thing in there?
no.
No, we're eating dead stuff, right?
Yeah.
Oh my.
No, I'm so serious.
Really?
If you set a Cheeto on
It's
fire,
corn that's been dead for weeks to months.
if you set a Cheeto on fire, it's not gonna burn. So
It's not going to scream or try to escape.
Right.
Right? It's dead.
that.
Can you imagine you burning a Dorito?
All right, so next up in orange are our consumers, right? And we're all familiar with this word to consume something, right? We go out there, we take it from where it is, and we bring it home or put it in our body or whatnot. Right, so when we consume something, we are removing it from its environment. Right, so consumers are heterotrophic, meaning they cannot make their own food. Right, so these are organisms that eat producers. They might also eat other consumers. Right, so you might be an animal. Right. That eat producers or other consumers. Now, when you were in middle school, you learned about consumers. You learned about a very simplified version of it. But we're going to extend on that since this is a high school course, and we're preparing you for an assessment on June 1st and 2nd. The next sentence, or the next thing that comes up, we're gonna play with. We're gonna abbreviate. So don't like pound it down right away. All right. So primary consumers, primo, prima, right? Prime first. Our consumers in this picture. Before you write this down, we can make this a lot shorter. What symbol did we use earlier to represent consumption? Earlier in the notes. The arrow. You can actually just take the arrow and put that, right? Primary is what eats the producer, right? That arrow symbolizes the movement of energy and matter of eating, right? So primary eats the producer, right? That arrow representing consumption, that representing eating. All right, so we have our primary producer. And then you have your secondary. We can do the same thing here, right? Your secondary is what consumes the primary. Now from here we're going to move into some Latin-based terminology. Right, so obviously we have primary, secondary, then you would in your head think third area or something. Where instead they use the Latin version, they use tertiary. Right, so tertiary consumes the secondary. And it goes on.
Oh
Now,
my God, where do you think I did?
what is the prefix? What is the prefix we've used to represent 4 in this class multiple times? Quad. Right, so there's also quattertiary. And then there's quintertiary, if you got 5, right? We're talking about levels. All right, now let's take what we've just done and apply it to our original food chain. So I gave you that list where you got sun, flower, insect, so on and so forth. Which one of the things should you color in green right now? Which one's our producer? The flower, right? So going back to our original do now question, right? Go ahead and underline the flower in green. Right, so we reinforce that that's our producer. All right, and our insect, our rat, our cat, our hawk are all what? Consumers, right? So go ahead and underline those in orange, and then put the appropriate numbers above them, right? So your insect, right, would be underlined in orange with the number 1 because it's primary. And I'll put that up here for those that don't follow verbal directions well. Right, so our insect is our primary producer. In our scenario earlier, our rat would be our secondary, our cat would be our tertiary, and if we wanted to include the hawk, right, that would be our quaternary.
We understood that.
Alright, our quaternary, great. Right, so what we've done is we've taken our do now and applied this to it. At 3 o'clock, you're welcome to go wherever you like. Alright, so this is terrible. Alright, so let's look at a little picture. Alright, up here we've got a nice food web. Now again, since we're talking about a food web here, let's move on parts of it. Let's talk about why it's a web and not a chain, right?
Because I want to talk about it. Let me talk about it.
Tell me some stuff.
Multiple animals eat like multiple things. Just like, let me see. Just like the snake can eat the rat and it can eat the bird and just like.
All right. So the mouse could be eaten by the snake or the salamander.
Eat everything.
Or the snake could also eat that bird. And who can eat the snake?
The hawk.
The hawk, right? Okay. So what we're gonna do with this?
Secondary what? Claudio?
Stop touching me.
All right. I don't know what's going on here. Turn it off. I don't want that. All right, what I'm going to ask folks to do is transform this into a simple...
Do we have to use every animal? He's like...
Alright, part where the teacher's trying to give directions, so people will be looking up front, not having their own personal conversations. Alright, so, okay, so, oh, it's frozen, awesome. Alright, in an ideal world, this will work. Just a moment. Hopefully something will happen that's good. Although that's never the case. Wait, no. Okay, I see what's going on. The smart board tools are on the wrong page. They're over here for some reason. Is someone trying to come back in?
Yeah.
Okay, great. Thanks for being patient during the delay, folks. All right, what I'm going to ask you to do is create a food cycle. By cycle, I mean the nutrients are moving in a circle. And to do that, there's several different paths we can take. All right.
Can I just write it instead of having to draw the
Oh, I get it. All right. Hold on.
Can I? Did you hear me?
No.
I said, can I just write the names of the organisms instead of having to draw the picture of those?
Whatever you'd like to do, computer, just throw it. Let's all get along. It'll be great.
It's back.
Yeah, but it's also got that crazy thing in the front that we don't want for it.
Drag it away.
All right, so that thing won't go away, and I can't click on the marker tools. Awesome. Okay, so let's just do it verbally, and hopefully folks can handle it. Given that you are... All right, things are happening that look good.
What are those?
Oh. Okay. I'm feeling good. I feel like good things might happen now. All right. What I'm going to ask you to do is follow several different possible paths. Right? What do you think these things are coming out of our decomposers?
I can't see.
Molecules. So we're going to start some molecules off with our decomposers. Let's say we start with this path. We go up to this thing. What is that thing there? A plant? It's a... From our vocab today, a plant is a... Giovanni, it's up here, not over there. And this producer insect. That makes this insect a
Consumer.
Primary.
primary consumer. And then if that insect is eaten by that bird, that makes the bird the.
Secondary.
And then if that bird is eaten by the hawk, tertiary. Great. Okay. Is the hawk going to live forever?
No.
Eventually he's going to die and be
Decomposed.
decomposed. Right, so there's one circle you could draw. Right? Another one you could do, right, is we can start with the nutrients, the molecules from our decomposer. They could nourish this acorn, this oak tree. The acorns are eaten by the.
What is that, mouse?
Yeah, and the mouse is eaten by the.
Snake. If you go to
And the snake could be eaten by the. And the hawk will eventually. Alright, so you can see how within this, there are multiple pathways in the drawing you do. Right, I'm just going to draw like the organism, also color it, right, with green for producer, orange for consumers, and what's the other one? Purple for decomposers. In that, you just need 3 consumers in your gold, right? So, right, so you should have 1 purple, 1 green, 3 orange. And you can see there's multiple pathways here. I'll show you another one for folks that are still confused. Right, so I can start with these decomposers, which nourish the pine. Right, the pine nourishes the insect, which nourishes the salamander, which nourishes the snake. Right, so there's another one that, of course, the snake dies, and it's the decomposers. Right, so you're creating a circuit, right, with these pictures. And I'll show you why at the end, because the MCAS drawings are generally like what you're creating right now. Yeah. All right, so at this point, this is the stage when the drawing is happening, right? I'm going to clear the marker stuff so people can see a little better. Again, you need the decomposers, you need a producer, and 3 consumers. Other than that, it's all yours. I'll also put an example on the board with a marine food chain. You could do mine as well, or one of these ones. It's all good.
Like a crawfish and whatever it was.
Yeah.
All right, so like a penguin, and then a seal, and then a whale, and then a shark, and do the fish. For the first time you didn't know like yellow algae.
Oh wait, I should do it in colors that match our notes. Otherwise, people will freak out. And then we'll know what to do.
What, Eric? What are you looking at? Huh? Who are you talking to? You. No, you're not. No, you're not. I'll smack you silly. I would. Stop.
You're a spin too, shut up. Do you clean your room? Do you wash? Do you clean your laundry? Then you're a spin, shut the fuck up.
Nope, just an
Exactly,
example.
shut up, shut up.
It'll be winter.
It's big, it's big. I don't do anything else. Clean my room.
Bueno, solo voy a abrir.
Yeah, I do Johnny.
Abrir. I know.
That's a lie. That's not a lie. That's a dead ass lie. What are you doing?
I would
No.
Speak, let go.
Happy birthday.
He said, roll it.
That's the one I had for my emblem.
But like, I didn't have early primary. You know, like, your fruit, and then I finished at 14. Your buns.
Girls like
All right, folks, I hear a lot of talking, but I don't see much
Everybody
writing.
like fruitcake on Christmas. I just last time I read it. I'm putting
All right, folks, so what I have drawn up there is an example of what yours should look like. Notice I've labeled each trophic level and colored them just like our notes. So you don't have to use mine, mine's an example, but you could do the same thing with these organisms here. Either way, we're representing this idea that the nutrients and the decomposers eventually make their way back to the producer, and then to the consumers, and then back to the decomposers, and so on and so forth. All right, so the